Thank you very much for the introduction. Good morning, everyone. My name is Adam, and I'm going to present my project, Minerva, the Mixed Initiative Interaction through Profile-Based Adaptive Systems, doing by me and my colleagues, Chris, Mika, and Kahoni Chanel. So we're discussing a lot today. Okay. Discussing a lot today about the mixed initiative interactions. So what we want to achieve, it's the real collaboration. So normally we see the artificial agents, the robots, being in the situations as a tool, but what we want is the artificial agents be a real teammate. He can actually do something, actually act in the activity and propose something during this activity. So with this active behavior, we think that the test can be done faster, or even more tests can be done if we have the trust between the human and the artificial agent. And sorry. And with this partnership contest, we expect that we have a real human agent collaboration. So what we understand is that in the part of the artificial intelligence, it's normally designed to be for a predefined scope, so has not a lot of skills, or even if they have a lot of skills, they have a lack of ability to show it to the human agent in the interaction. And about the human, we have the human has a lot of abilities to adapt to any situation, to any context. And normally the human has a lot of preferences. We're discussing about trust, we're discussing about things that they want, and this is important during a task. But you can have some issues in trust in artificial teammates. So our question is how good or how well these heterogeneous agents, the human and the artificial agent, can work together. So we have a definition about what is the human agent collaboration. So you understand the human and the artificial agent are working, are doing some actions and having feedback about the task, about the environment, or about a mission. And this is normally discussed as a performance. It's important to a task, but in our opinion, it's also important the human and the artificial agent having a fluent interaction. So they understand each other, they know what the other can do. And with this, we think that with a better interaction, with a fluently interaction, we will have a better performance in the activity. So that's our definition about the human agent collaboration. In this context, we designed the Minerva project. The idea is the artificial agent help the pilot during a landing situation, emergency situation with a landing obligation. So we want to understand the correlations between the pilot profile or the pilot preferences and the tendency to accept or not certain ads that the artificial agent can provide. We understand that this situation, the emergency situation with the land obligation, is a hard test situation to the risk, doing the time pressure, and even inside the aviation that you have a lot of checklists, a lot of procedures that you have to follow. You may have some preferences even in this kind of situation, and you want to understand what kind of preference or what kind of ads you can select during this moment. So our hypothesis in this work in progress work is profile-related information will be used to change the behavior of the agent, the artificial agent, helping the pilot during the emergency landing. Indeed, improving the fluency and then the performance of the collaboration. So we have three main objectives. Right now is defining the fluency metrics that can be used online, because we're discussing about changing the behavior during the emergency situation. It's something about five minutes maximum in our case. So we need to understand in that moment what to change. Build behavior, physiological, and fluency-related database. And with this information, we want to develop a decision-making model to adapt the artificial agent actions or the behavior. So this is the scenario that we designed so far. we have the we have a Robin D Catsan D400. It's a normal pilot, a normal plane here in France. But there's no a lot of information. There's no more signs. There's no more that the pilot can have information about the flight. We're planning to get the plane until 4,000 feet, more or less. And in this moment, at any time, we have in the emergency situation. So it's going to start to flame. The plane is going to get to flame, and then the pilot can select some ads from the artificial agent or can work by himself. So you're using a lot of materials. You're using the ECG, the eye tracker to understand the behavior activity inside of a simulator that we use right now, the X-Plane 11. And that's the final ads that we have. I understand I have mostly no background in aviation, but I understand that for main phases of the aviation, that is aviate, navigate, communicate, and manage, and you want to give again to help the pilot in all these cases. I'm going to pass with you one by one and discuss these helps that we are defining. First of all, it's because about the manage. It's normally understanding the situation of the plane. So we have two possibilities. One is just doing the monitoring. So the pilots should check some instruments or should do something or during the checklist. The pilot has to do something and say, I did this, and the artificial agent are monitoring if they're really looking, really doing everything. Or the other possibility is to be totally autonomous. So the artificial agent will do the checklist, will push the buttons, will do everything and give the feedback for the pilot. So it's saying, I did this, and the pilot can see that it really happened in the inside of the plane. The other one is about the Aviate. It's actually an autopilot. So you can ask to the artificial agent to keep the flight or change altitude, change some speed, the airspeed. So it's actually it's simple. It's a simple autopilot, but you can discuss with the artificial intelligence. One of the most complicated one is the navigator, understanding where I'm going to head my plane, understanding the checkpoints that I have, because it's a emergency situation. You probably not going to land in an airport, so you need information to understand how you can find a better place to land. And the communicate phase that you can really discuss with the ATC. Of course, we are in a simulator, so I understand that the real discussion with someone is really complicated, but inside of a simulation, we have a scenario, a basic scenario, so you can understand, you can discuss with the ATC. This part of the communication we are doing using an enhanced version of a previous student project supervised by Dassault Aviation. This is the experiment protocol. So our idea is doing, after we understand put the installation of all the sensors, we want to do a training session that the pilot is flying and can test all the possible ads. And after that, when the pilot seems comfortable, we start the real experiment. There's two types of two conditions. One is no control at all, no ads, so it's the control, sorry. So it's just the pilot flying. And the other condition is the pilot can select any help. He can select any ads at any time. So these conditions will be pseudo randomized, so we understand all the possible preferences, all the possible profiles. So we're expecting a number of participants of 20 or 80. I know it's really different, the two numbers, but we started discussing about 4 different profiles. But previous results, actually, preliminary results in another experiment that we are doing, we saw that here in ISAE-SUPAERO, we have only 3 profiles. And not even with this 3, there is one that is more we see all the time. So you may understand that probably pilots has not that many of profiles, so you don't need all of the 80 possible participants, but we need to test this. Sorry. This is the architecture that we are working right now. I'm not going to pass for all of it, but the idea is we have a listener node working with Ross. So we have a listener node that starts all the recordings about the behavior. It's the keyboard entrance, the pupil labs. The pupil labs is the eye tracker, and the ACG. And it's got to recording all the information since the beginning of the experiment. And we have a maestro node that is defining the edge. So anytime that the pilot asks for something, this maestro node selects which node is going to be activated. And this information is also recorded. So we are recording all the information about the pilot and all the information about the plane by the simulator. So everything there done, all the situations are being recorded to understand what's happening. And this is the expected results. So you want to characterize this pilot's preferences and analyze the choice that they do, given a mission context. You understand that in some situations, they're going to select one ad or not or other. And we think that these preferences are related to the profiles. So that's what we want to see. It's, as I said, as a work in progress. And we want to show that we can help the pilots with the ads that we propose. So we have the analysis of the behavioral and physiological features, the subjective features in the questionnaires, and also the performance. We have a performance, how good you are in the landing moment. And with all of this data, we are going to develop the decision-making probably using POMDP, but it's discussing a decision-making model that is capable of acting. That means driving the artificial agent behavior towards the mixed initiative interaction. And after that, we want to evaluate in a second experimental campaign, we want to evaluate the automatic launch of the ads. So understand the relevance of the ads and if we can see if we can predict when the pilot wants each kind of ad. And that's it. Thank you very much.